Hey everyone, and welcome. So, are you ready for a really fun math challenge? Today, we are going to unlock a super cool math power called Factorials. Let's jump right in. So, have you ever been doing your math homework and you see this little exclamation mark right next to a number, and you're just thinking, wait a second, why is my math book shouting at me? Well, I've got good news. It's not angry. It's actually kind of a secret code for something really, really awesome. Okay, so that little exclamation mark, it's called a factorial. And all it means is you multiply a number by every whole number that's smaller than it, all the way down to 1. So for example, if you see 4 factorial, that just means 4 times 3 times 2 times 1, which equals 24. Pretty simple, right? Oh, and there's one special kind of weird rule you just have to remember. 0 factorial is always 1. Just trust me on this one. It's a super handy rule that helps a lot with more advanced math later on. All right, now that you know the basics, I think it's time for our first challenge. Let's call this one the warm-up. Okay, here's our problem. We've got 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial. Why don't you try to solve this along with me? The key here is just taking it one tiny step at a time. Okay, let's break this down piece by piece. First up, 1 factorial. Well, that's just 1. Easy. Next, 2 factorial is 2 times 1, which is 2. Simple enough. 3 factorial is 3 times 2 times 1, which gives us 6. Then we've got 4 factorial, that's 4 times 3 times 2 times 1, that's 24. And last but not least, 5 factorial. That's 5 times 4 times 3 times 2 times 1, which gets us all the way up to a whopping 120. Awesome! So we've got all of our individual pieces figured out. Now for the final step. All we have to do is add them all together. 1 plus 2 plus 6 plus 24 plus 120. And the answer is, drumroll please, 153. Yes, awesome job. You just totally crushed the first challenge. See, I told you factorials aren't so scary. Okay, warm-up complete. You're ready for challenge number 2. Now, for this one, you're going to need a clever little trick. This is where the real fun starts. All right, take a look at this monster. 100 times 99 factorial minus 100 factorial. Now, you could try to calculate 100 factorial, but trust me, you don't want to. That number is gigantic. We're talking more than 150 digits long. There has to be a secret, a much easier way to do this. So let's just look at the two parts of our problem here. On one side, we've got 100 times 99 factorial, and on the other side, we have 100 factorial. Do you see any kind of connection between them? Really think about what 100 factorial means. Okay, you ready for the secret? 100 factorial is just 100 times 99 times 98 all the way down. But wait a minute, look at that part from 99 all the way down to 1. What's that? It's 99 factorial. So that means 100 factorial is exactly the same thing as 100 times 99 factorial. Now that is our aha moment. So if we look at our problem again, it just got way, way simpler. Since both sides of the minus sign are actually the same thing, we're really just asking a simple question. What happens when you subtract a number from itself? And the answer is, of course, 0. How cool is that? You just solved a problem with these massive, gigantic numbers, and you didn't even need a calculator. That's the power of thinking smart instead of just trying to calculate hard. Okay, you've totally mastered the basics, and you've learned the clever tricks. Now, it's time for the final boss. This is a real problem from an actual national math competition. But don't worry, you are so ready for this. Let's really break down what this question is asking, okay? It wants to know if we add up these 3 huge factorials, 98, 99, and 100, how many times could we divide that final answer by the number 5? That number of times, that's going to be our answer n. I know this looks super complicated, but we have a solid 2-step battle plan. Step 1, we're going to simplify that big, messy addition problem. And step 2, we'll go on a hunt to find all the factors of 5 that are hiding inside. Let's do this. All right, let's start with step 1. Just like in our last challenge, all these factorials are related to each other. The smallest one here is 98 factorial. And that means we can find a 98 factorial hiding inside both 99 factorial times 100 factorial. So guess what? We can pull it out. We can factor it out.
let me show you exactly how that works. We're going to pull out that 98 factorial. So from the first part, we're just left with 1. From 99 factorial, remember that's just 99 times 98 factorial, so we're left with 99. And from 100 factorial, which is 100 times 99 times 98 factorial, we're left with 100 times 99.
Okay, now we just have to simplify what's inside those parentheses. So 1 plus 99, that's 100. And 100 times 99 is 9,900. So we've got 100 plus 9,900, which is 10,000. Would you look at that? That whole huge, crazy sum simplifies all the way down to 98 factorial times 10,000. Step 1, complete.
All right, on to step 2, the great factor hunt. Our problem is so much easier now. All we have to do is find all the factors of 5 hiding in 98 factorial, and then find all the factors of 5 hiding in 10,000, and then just add those two numbers together.
So the big question is, how in the world do we find all the 5s in 98 factorial without writing the whole thing out? Well, there's a really cool trick. First, let's just count all the multiples of 5, like 5, 10, 15, and so on. We can do that by dividing 98 by 5, which gives us 19. So that's 19 factors of 5 right there. But hold on, some numbers, like 25 or 50 or 75, are extra special. Why? Because 25 is 5 times 5, which means it gives us an extra factor of 5 we need to count. So let's find those. We divide 98 by 25, and that gives us 3. So we have 3 extra factors. Now we just add them up. The 19 we found first, plus those 3 extras, gives us a total of 22 factors of 5 hiding in 98 factorial.
Okay, the second part of our hunt is way, way easier. How many factors of 5 are in 10,000? Well, think about it. 10,000 is just 10 to the power of 4. And what's every 10 made of? A 2 and a 5. So if we have 4 10s, that means we have 4 5s. Simple as that. Okay, we are in the home stretch now. All we have to do is combine our results. We found 22 factors of 5 from the 98 factorial part, and we found 4 factors of 5 from the 10,000 part. So let's just add those up. And that means the final answer is 26. We did it! Victory! We have officially defeated the final boss. The largest integer n is 26. You guys, you just solved a real-deal math competition problem. So let's take a second and recap this new math superpower you just learned.
Think about it. In just a few minutes, you went from asking what in the world is a factorial to solving an actual national math competition problem. If that's not a superpower, I don't know what is. You learned that even the most complex problems can be broken down into smaller pieces. And sometimes the smartest solution isn't about doing tons of calculations. It's about finding that hidden pattern. So the next time you see a weird symbol in your math book, remember, it's not shouting at you, it's inviting you to solve a puzzle. My only question is, what puzzle are you going to solve next?